Hello, my name is Christopher DeLay, and here I am continuing this series on PKI basics. So the first two videos in this series cover certification authorities and certificates, and this third one's going to cover certificate validation. So again, at the beginning of each video, I like to emphasize that I'm starting this series kind of at a very high level. So the concept is that these videos would be for somebody who's new to PKI and new to certificates that are trying to learn this. Now, obviously, since that's the case, I'm going to start out with a higher level view, and then as time goes on, I'll progress into more detail. So in this video, we'll cover how certificates are validated. I won't specifically cover the troubleshooting steps you would do to check that validation, but I will do that in upcoming videos. So this is just going to be just basically on the concepts. So if you do like this video, feel free to pass it along to others. Go ahead and feel free to, you can visit my blog as well. If you want to leave comments, you can leave comments under the video or at my blog as well, which is listed here below. So we're going to cover how our certificates validated, certificate chaining, revocation, CRL distribution points, and online certificate status protocol. So probably one of the most confusing things to those folks that are trying to learn PKI is certificate validation. And this is really where you run into probably the most issues from a troubleshooting standpoint. So usually when certificates fail to work, it's usually because of the reasons listed here. There's another topic in here that I hopefully remember to bring up, and that is basically certificates have different purposes they can be used for, so that's something you may want to validate as well. So when you're thinking about a certificate and how it's being validated, you need to think about who's doing the validation, right? So if it's a client, if it's your client going to a web server and it's going to a TLS protected website, then the certificate validations actually happen on your computer, your client, right? So that's where you need to kind of figure out where the problems are arising. So the first thing, well, these aren't checked in any particular order that I know of. However, the first thing we're going to cover is identity validation, right? So you all have had the situation where you've gotten a similar error to the one listed here on the slide. So the thing is, the identity in the subject or the subject alternative name should match the identity that you know that you're going to in a browser or that your application is going to, so that name should match. So if you're going to www.microsoft.com, then you would expect that name to be somewhere in the cert, either in the subject name or in the subject alternative name. One thing about TLS is if the subject is empty, then this subject alternative name must have values because we have to have identity somewhere in the certificate. And another thing to think about is if the SAN is populated, then the subject is ignored. So it doesn't really matter what you have in the subject at that point. And that's particular to TLS. That may work differently with different other protocols, but just keep that in mind when you're doing that. So if you had both fields populated, you would definitely want to make sure that you have the name that you have users going to in the subject alternative name if you're using the subject alternative name. The next thing that we're going to cover is chain validation, right? So PKI is built on this kind of trust model, where if you trust the root CA, then you trust the CAs and certificates underneath it. So whatever certificate you're using definitely needs to be trusted. In Windows, that is the Trusted Root Certification Authority store. And how certificates or root CAs become trusted, there's various ways. So there are ones that ship with Windows by default, and that's part of the Microsoft root program. You, in an enterprise or corporate environment, you may deploy your own PKI into the Trusted Root Store or other PKIs that you trust. So this is where all the trusted roots would be. So this is really kind of from a security standpoint, it's something you want to keep tabs on, because if a certificate's in here, then the client's going to trust it or the server is going to trust it, And if it's not something that's trustworthy, then it's definitely something you don't want to be in here. There's definitely technologies like certificate pinning and other things that you can use to accomplish that, but that's kind of outside the scope of this video. So does today's date and time fall between the valid from and valid to dates, right? So the certificate needs to be time valid. It needs to be in between these two dates and times. If it's not, then it will definitely not be considered valid. And certificates have a built-in limited validity period so that they actually do expire at some point, and that's kind of a security feature of certificates, that they're not good forever. So eventually they drop off from being trusted once they expire. Certificate chaining. So we're going to cover how certificate chaining works. So previously I kind of talked about how the root certificate needs to be trusted, but the thing is, in order for the cert you're validating to be trusted, you have to be able to discover that it is actually chained to that trusted root, and that may not be readily apparent. So there's sometimes some additional checks and steps that need to be done to accomplish that. So we'll get into that in a second, but this is one example that shows how Windows can determine if a certificate chains to a trusted root. So in this example, on the left we have the end entity certificate, and then in the middle we have the CA that issued that certificate, and then in the right hand side we have the root CA, which issued the CA that issued the end entity certificate. So you basically have end entity certificate, issuing CA, and then root CA. So if we look and see if I can use like a magnifier to make this a little bit better. Okay, so right here, so here's the end entity certificate, and there's what's called the authority key identifier. So it's basically a thumbprint of the public key of the issuer. So this gives us information about the issuer. So this should match up to whichever the next certificate in the chain is. This should match the subject key identifier in the next cert in the chain. And if we go over here, we see that that actually matches the subject key identifier in the next cert in the chain. And so this is going to continue on to all the way to the root. So the PKI field in this issuing CA should match the root, and we see that it does. There are other ways to do matches, like name matching and other things like that, but we're not really going to cover all that. I just wanted to give one example. Keep in mind that the signatures need to match up. So remember, this root CA signs this issuing CA certificate with its private key, so we can validate the signature with the root CA's public key. And this issuing CA certificate issues this end entity certificate, and it signs this certificate with its own private key. And if we have access to the CA's public key, then we can validate that signature and validate that those signatures line up as well. Chain building in detail. Basically, you can read this or not read it. I'm going to reiterate it without reading the slide. So you need to find out if the root is trusted. You may, as in the previous example, have like those three different levels. You have the end entity, the issuing, and the root. So you need to, in order to determine that that end entity cert basically maps or chains all the way to the root, you need to have that intermediate certificate or issuing CA certificate. So it gets a little bit confusing because sometimes those intermediate CA certificates are called intermediate CAs. Sometimes people call them subordinate CAs. Sometimes they're called issuing CAs. So this is some of the different terminology you may hear. So in order to determine, like I said previously, in order to know that that end entity cert chains to that root, then you need to have that intermediate cert. So like Windows clients, if you have your own internal PKI in your corporate environment or whatever your organization is, all the chain gets pushed down to Windows clients through Active Directory. So all the Windows clients will have the root, the subordinate, and the root CA so they'll have the two CA certificates already trusted. And there's possible in some situations where that may not be the case. So you could imagine if you're out there browsing the internet, you may go to a website and your client may go to validate that certificate, and if it is something that's going to be trusted, obviously you have the trusted root, but you may or may not have the intermediate. So there's a way to go ahead and fetch that intermediate certificate, and that's called the Authority Information Access field. That AIA field contains URLs, as we'll see in a second, of where that CA certificate can be retrieved from. It's also, to hopefully not make this too confusing, the AIA extension can also hold like a URL to the OCSP server, and the OCSP server is something totally different. That's just that's a way of checking revocation status, which we'll take a look at towards the end of this video. So time to go to the magnifier again. So here we have a certificate, and I'm just showing the Authority Information Access extension in this particular certificate. So in this particular certificate, there's two ways to access the AIA. So one is LDAP. So if you're using like a Microsoft PKI, then and you use LDAP, it means typically means that your CA certificates are being published to Active Directory and retrieved from Active Directory. So this is an Active Directory location. So there's an LDAP path here that you can go retrieve the CA certificate from, and then there is the there's an HTTP path as well, so like a web server where you can go ahead and retrieve that. So just to go back and kind of talk about the chain build, the AIA paths, to make it a little bit more clear. So we have these three CAs, right? So, well, I'm sorry, I misspoke. Two CAs and this end entity cert. So this root CA is going to have an AIA location in its certificate, and that's where that certificate can be retrieved from. It would be, you'd only be looking for it if you were like validating this intermediate certificate, or trying to chain it. The thing is, for the roots, even though the root CA certificate has an AIA location, well, actually that's not true. The root certificate does not have an AIA or CDP location, so I really misspoke there. But in this sub CA or intermediate certificate, there is an AIA location, and that's where you can retrieve the root certificate. Although it's kind of common practice to have an AIA location in this intermediate certificate, it's not really all that helpful, because in order for this to work, you're going to have to already trust the root. And if you have if you trust the root, you already have possession of that certificate because it's already installed somewhere on your system. If it's a Windows system, then it's in the Trusted Root Certification Authority store. If it's Linux or an iPhone or whatever, it's going to have its own store, either for the OS or for the application. So the AIA isn't really that helpful in the intermediate certificate because you already have the root. Now this, so that's going to be the AIA that's stamped in this intermediate certificate. So root has no AIA defined. This has an AIA defined that tells us where to download the root. And then this end entity certificate is going to have an Authority Information Access field, and that's where you can download the intermediate certificate. So in a typical scenario where you would scenario where you would actually use the AIA would be that you already have the root, you have this end entity certificate, you got it during the TLS negotiation, whatever the case may be. You got this end entity certificate because you're validating it, hence you must have possession of it. So the one you may be missing is this intermediate one. So we're going to be looking at the AIA location and the end entity certificate to retrieve the intermediate. And then once we have all three, we can build the chain. And if the chain terminates or ends in a root that is in your Trusted Root Certification Authority store, then the whole thing's trusted, including the end entity certificate. So let's see a little bit more about AIA. So basically, like I said, it is that extension in the certificate where you can retrieve the CA for the issuer. Like we saw in the earlier example, the AIA repository can be either an HTTP or a CDP location, and you can have multiple repositories. So you could have any combination. You could have two HTTP locations, you could have an LDAP location, then an HTTP location, you could have an HTTP location and then an LDAP location. Anyways, I mean, there's no limit to two. I imagine you could put as many as you want, but there's a timeout. So Windows, I think there's like a 15-second timeout. So 15 second, yeah, I think it's 15 seconds. it'll try to retrieve from the first repository, and then I think after 15 seconds it'll try the second one, and I'm not really sure what the timeout is after that. But so the order that they're stamped, if you will, in the certificate matters, because the first one will be retrieved first, and if that's inaccessible, I'll go to the second one. As mentioned earlier, the AIA location is also where OCSP services URL can be stamped, so you can do revocation checks on that. Going into a little bit more on this, so as far as the HTTP location, that's commonly the best practice to use HTTP because that's accessible by all types of clients. Also, if you're using certificates externally, HTTP is what we call firewall friendly. We all know how to secure HTTP onto the public network or internet, so it makes it easy to do that as well. And we all know how to make, although HTTP isn't high available by default, it's something we're all used to being able to do, is make websites highly available, right? Have multiple websites behind a load balancer. So it's a pretty common way to handle that. LDAP, again, is another place that can be stored. The advantages to LDAP is if you are on the local Active Directory, then there's the DC locator, so you go to a site that's closest to the client, so that's one advantage. AD, since the AIA, since the certificate would be stored in the configuration partition, that's like replicated to every domain controller in the forest, so there's a high availability aspect as well. So obviously, like, websites can be made to be kind of what is it? So what would be the word here? Where it would be, I'm not finding the word I'm looking for, but basically, usually websites are not necessarily site aware. However, you can do, if you have a, let's see, a load balancer with enough features and you have web servers in multiple locations, then you can configure a load balancer to send the client to the web server that's closest to them. So that's something that can be done. It's just you have to have the hardware and or software to do that. So we talked about chain building and the trusted root and all that. Now we're going to move on to revocation. So basically, once certificates are issued, there may become a reason why they're not trusted. It could be the machine was compromised, somebody lost their laptop, somebody lost their smart card. So when those certificates are not trusted anymore, they can be revoked. And what happens is the administrator will go into this certificate services or certification authority, MMC. They'll find the certificate, they'll right click on it, they'll revoke it, and they'll provide a reason for revocation. There is an unspecified reason. There's a number of reasons. I don't remember if I have them all. Actually, they're on the next bullet here. So there's an unspecified, key compromise, CA compromise, change affiliation, superseded, CISO operation, certificate hold. And whenever someone talks about CRLs, they usually bring up this certificate hold reason because it's the one situation where, like, you can natively just kind of like unrevoke the certificate. So you could, if somebody was out on leave, you could put their certificate on hold and then basically unrevoke it later. Obviously, if you were clever enough to be able to know how to manipulate the CRLs, I guess theoretically you could really unrevoke anything by just removing it from the CRL. So that's definitely an option to do that. But typically the on hold reason is the only reason where you would go through and unrevoke it. So certificate revocation list. So like I said, once the administrator goes in and right clicks on it and revokes the certificate, event periodically the CA will publish a CRL, and what will happen is that serial number will be published, will be put in that CRL. And that CRL is published to what we call a CRL distribution point, and that's the repository where clients go ahead and access and download those CRLs. So there are base CRLs and delta CRLs. So base CRLs contain all it should be all non-expired certificates that have been revoked, and delta CRLs should be all non-expired revoked certificates that have been revoked since the last base CRL was issued. So typically there's no need to have expired certificates in the CRL because they're no longer valid. So, and also if you can remove, if those expired certificates are removed from the CRL, then it kind of helps decrease the size of the CRL, because the CRL is a file, and as you do revocations, you add to that file size. And if you're a large enough organization and do a large enough number of CRLs, and obviously you can run into size issues with the CRL file. And if clients are trying to download that before they get on the network, that can cause problems. There's also, if you're storing your CRLs in LDAP, which we'll talk about in a second, then there are certain replication limitations in Active Directory. And so I think once your CRL gets above like 13 megabytes or something like that, then it will cease to replicate in Active Directory. So there's a bunch of different problems you can run into with larger CRLs. But the point here is that the administrator revokes certificate, eventually gets published to a CRL. That CRL eventually gets published to a CRL distribution point, and the clients can access that CRL from the CRL distribution point, which is stamped in the certificate. So basically what I said before, when you revoke the certificate, basically a serial number gets added to the CRL and the time of revocation and the reason that it has been revoked. It is kind of like, it is a signed file similar to a certificate, and so it does have a period of time for which it's valid for. So not only do you have to have access to the CRL, you have to have access to a CRL that's time valid. And again, the CDP location is located in the CDP location is located in the CDP extension of the certificate being validated. So there's a CDP extension that you'll see in the certificate. So here's an example of a CRL. So this is a base CRL, and we'll see that one field here is the version, and this just tells us this is version 2 of the CRL profile, which is the most current version. That's typically what you'll see. Who is the publisher of the CRL? So there's typically, well, I think it's almost always going to be the CA that issues the certificate is also going to be the issuer of the CRL. So here we see the issuer of the CRL is this Fourth Coffee issuing CA01. We see here the validity period. So effective date is when the CRL is first valid, and then the next update is when the CRL basically expires. So what algorithms are used to sign the CRL? So SHA, in this example, it's SHA-256 RSA. So SHA-256 is the hashing algorithm, and RSA is the asymmetric cryptographic algorithm. So when you sign a file, you basically run it through a hash, and then the result of the hash is encrypted with the private key of whoever's signing it. Then the validator, whoever's going to validate that signature, they get a copy of the file, run it through the same hashing algorithm, and that information about what a hashing algorithm is usually in some kind of header information. But anyways, the validator kind of runs that file through the same hashing algorithm. Then they get a copy of the digital signature, and they decrypt that with the RSA key, and then they compare the two hashes, and if they match, we know that the file has not been altered. And we also know who actually signed that, because only that person or service or system should have access to that private key. And you're, again, I didn't mention this, you're decrypting that file with the public key. So this is the hash algorithm that's used. This is another way of identifying the issuer of the CRL. So this is the authority key identifier. We saw this earlier. It's basically a thumbprint of the issuer's public key. So the slide's a little messed up. So what this should be is, if I can fix this without causing too many problems with this presentation, should be the CA version. So the CA version is the version of the CA certificate. So this is version 1.1. So this means so certificates start with 0.0, and then if they're renewed with a new key pair, the left side of the decimal ramps up 1, and if they're renewed with the same key pair, the right side of the decimal increases by 1. So this certificate would have been renewed once with a new key pair and once with same key pair. What version of the CRL? So this is just the, these kind of go in sequential order. So this is which number the CRL has been issued. And this can become important, especially when you're issuing delta CRLs. It'll allow the client to determine, which delta CRLs are acceptable to use with the base CRL. So these definitely do come into play, but I'm not going to go into too much detail on that. So next CRL publish is when the next CRL is expected to be published. So, for a Windows CA, this is in fact when the next CRL will be published by the CA. So the way that kind of works is that, so let's see, how does that work, right? So this will allow clients to know when the next CRL is published, obviously. And so the idea here is, if you look at this example, is this a good example or no? Now this is kind of a bad example. Like, this is not like a CA that's kind of set up well, because you'll notice this next CRL publish is not that long before the CRL expires. And so you could have, if my CA were to fail on October 25th, then I'd only have a day to bring the CA back up before the CRL expired. And if I had some sort of failure on the CA and I wasn't able to get it back up, then the CRL would expire. And then clients that do revocation checking would start to fail if the CRL was the only mechanism for checking revocation. So this is not a well set up PKI. What I would like to see is, like, this effective date be October 23rd, this next update be October 29th, and then this next CRL publish be October 26th, because that way on either side of that next CRL publish, I always have 3 days to recover the CA, at least 3 days to recover the CA and get a CRL sign. Now that's the CA sign the CRL. There are other ways in an emergency to sign a CRL, so you can do what's called emergency CRL signing. This requires you to have access to the CA's private keys, and then there's basically some commands you can run to re-sign the CRL. There's also a group policy. I'm not sure if I have in this slide. I don't think I do. There's a group policy that you can add to extend the life of the CRL and OCSP responses. Now, of course, it's a group policy, so that's only going to apply to domain join Windows clients. What certificates have been revoked? So again, we see the serial number in here and the revocation date. And if I were actually to click on that serial number, it would show me the reason for revocation down here. So Delta CRL contains a list of all non-expired certificates that have been revoked since the last base CRL was published. Must be time valid. And then in the CDP location, the Delta, there's basically in the Delta CRL, there's a freshest CRL extension. Oh no, I said that wrong. In the base CRL, there's a freshest CRL extension, and that gives us the URL of the Delta CRL. So the way it works is you would read the CDP in the certificate to find the base CRL, and then the freshest CRL extension in the CRL to find the Delta CRL. So how does this all work? So on some CAs, you may just have base CRLs. Depending, like if it's an offline route, you'd only have base CRLs. Depending on how you designed your subordinate CA or issuing CA, you may have Delta CRLs, or you may not, or you may just have base CRLs. I generally avoid Delta CRLs for a variety of reasons. One, they usually have a short life, which you run into the issue where if your CA fails and you can't sign a new Delta CRL, then you're going to start having problems. And they do add complexity, as you saw. I got to check the CDP, and then I got to check the freshest CRL extension. There's just a number of problems, so I try to avoid them unless there's a specific need for Delta CRLs. And that specific need would be, it could be you need to get more frequent revocation information. I guess that could be the case, but you could just republish base CRLs more often to get that. Some would say, well, this way, if you use Delta CRLs, you just have to download the base once, and then until the new base is published, you just have to download these Delta CRLs, which are going to be smaller in file size. I guess maybe that helps a little bit, but if you're running into file size issues, you're still going to have issues downloading the base curl. So if anybody wants to dispute this or argue this with me in the comments or in my contact information, my blog, I'd be happy to discuss this, but I personally am not a big fan of delta curls and generally don't recommend them. If you have a different viewpoint, I would be interested to hear that. So in this specific example here, we have base curls and we have delta curls. So at time 0 here, we have a base curl published, and then at time 1, certificate 3 is revoked. And so, and then at time 2, the delta curl is published, and then, let's see, start all over here. So time 0, the base curl is published, and it has certs 1 and 2 as revoked. And then at time 1, certificate 3 is revoked. And then at time 2, the delta curl is published. And then at time 3, we check revocation. We see that the base curl has certs 1 and 2 revoked, and that the delta curl has cert 3 revoked. As you can hear just by me going through that, it does become a little bit complex with the base and delta curls, so that's why one reason why I try to avoid them. So remember, when we're looking through the curls, what we're looking to is if we went to a website, and web browsers I don't usually believe do revocation checking, but let's say that is enabled. If I go to a website and I'm doing TLS and I decide there's a certificate I want to validate, I would take the serial number of that certificate, and that's what I'm looking for in the curl. So I'm going to download the curl, and then I'm looking for that serial number in the curl, and if it is in there, then the certificate's been revoked. So CRL distribution points. So again, there's a CRL distribution point extension, and that's where we can download the curls. Similar to the AIA, there's a LDAP location and there's an HTTP. Well, no, there isn't have to be, but you can use either and or HTTP and or LDAP location. So similar to the AIA, you could have one HTTP, you could have two HTTPs, you could have LDAP then HTTP, and HTTP then LDAP. So any combination. Same rules for the AIA apply. They're going to be processed in the order in which they are listed in the certificate. So whichever one's listed first is the one that's going to be checked first. If it's not accessible, there's like a 15-second timeout, and then if it can't download the first one, it'll download the second one. So just jumping ahead. So the same things are going to apply that we talked about AIA extension. So it's the same rules with HTTP and LDAP, right? It's the same advantages and disadvantages that we talked about prior, so I'm not going to go into maybe as exhaustive detail as I did before. But again, HTTP is the recommended one because it's available kind of by all devices. We know how to make it available on the internet, and yeah, we know how to make it highly available. We know how to make it kind of site aware if we want to do that, so HTTP is the recommended way. The other way is LDAP, which of course for Windows would be Active Directory, and then there's some things with Active Directory that are helpful, that it is stored in a configuration partition which is replicated forest wide, so we have high availability, and then DC Locator will find the domain controller that's closest to the client. Obviously, domain controller is a bad idea if you're using certificates externally, because doing LDAP over the internet would be kind of weird, and then second of all, making your domain controller available on the internet would definitely not be a very good practice. So as you can see, for a lot of situations, you just want to use HTTP. Some organizations do HTTP and then LDAP, and that's a thing as well. Still, the best practice is just HTTP. Also, LDAP has the, if you publish, like if you're using certs externally and you publish like an LDAP, you have like an LDAP CDP in your certificate, or if somebody gets a externally is checking a certificate or something like that, they can look in, you know, if you have like a web server that's secured with an internal certificate, and you have these external things, and you have the external AIA and CDP, and you do have that LDAP location maybe in there. Maybe you don't have LDAP accessible over the internet, but it's still over there because all your certs have that. Then if like somebody looks at that certificate that's on that web server, they can kind of figure out what your Active Directory domain name is, and depending on how the CA is configured, potentially the name of the CA. So online certificate status protocol, this is just another way to check revocation status. The problems are that CRLs can get large over time, and downloading large CRLs can affect performance. They can have issues with Active Directory replication. So those are some of the issues. And sometimes applications can time out while downloading large CRLs. So we can definitely have issues in terms of performance and downloading and stuff like that with CRLs. And also clients have to parse the CRL, which I guess is probably minimal computing resources, but nonetheless it is computing resources that need to be used on that. So basically we're going to talk about how the mechanics of this, how this works. So there's this OCSP URI that's stamped, or your URL, what do you want to refer to it as, is stamped in the AI extension of certificates, and this is how clients know where to check for the OCSP server. So basically, client determines the URI either through GPO or reading. So basically when the client's checking the revocation status, they'll look in the AIA location to see if there's an OCSP location to go to. Also for Windows clients, there's a GPO you can configure to have clients look in that OCSP server, even if there is not one defined in the certificate. So if the client sees that, then they'll send a request to the OCSP web service saying, hey, I got the certificate, here's the serial number, is it revoked or is it not revoked? And then the server will check to see if it's revoked or not revoked, and then it will go ahead and send a signed response back to the client. And so the OCSP responder has a certificate and private key, and so it signs the response and sends it back to the client. That way the client can validate the response by validating the signature on the certificate and validating that it's a certificate that it trusts, and other things we talked about earlier. So here's the process in a little bit more detail. So the OCSP responder determines if it has any cached responses. If it does have a cache response, in other words, like a client had previously asked, then it will send the cache response back to the client. If there are no responses available or non-support is enabled and on the OCSP responder, then the responder is going to have to go through and provide like a fresh response to the client. And so a nonce, been pretty horrible at explaining this, but the nonce is some information that the client passes in their request, and the client expects to receive that information back in their response. So it's a way to make sure each response is unique. Usually I think it's Cisco devices that usually have that enabled, so usually you have to enable non-support. A lot of times for Cisco devices, other devices may require it as well. Anyways, then the OCSP responder generates a response, the response is signed, and then it's sent to the requester, right? So that's how the OCSP server is working. And then we get a response. Here's an example of a signed response. In this specific example, if we find our laser pointer here, we can see that the response here is object basic good cert status. So it's saying that it's basically not revoked. Obviously this is a very old screenshot from like 9 years ago, but never mind that. So when we do revocation checking, so we just talked about CRLs and we talked about OCSP. Now we're just talking completely about the whole picture in terms of revocation validation. So the client, and by the client I mean who's ever validating a certificate. I don't mean that it's not a server. It could be Windows 2016 server. I'm just talking about a client in the aspect that it's validating the cert. So basically the client will check every certificate in the chain with the exception of the root to determine if it has been revoked. So we don't check revocation on the root because either you trust it or you don't trust it. If you trust it, then it's going to be trusted. If you think it should be revoked, then you just don't trust it, so then we won't really worry about revocation. So for each certificate, if an OCSP URL is configured by a GPO, it'll use that URL that's configured in GPO to query the OCSP server. If that's not present, then it'll try the OCSP URLs that is present in the AI extension and query the OCSP responder. And then if the OCSP URL is not present or accessible, it'll check the CRL distribution point and go to download a CRL and see if it's revoked. So basically, the point here is that all certs except for the root are checked for revocation, and it will try OCSP first, and then it will check CRLs if the OCSP is not available. There's one huge caveat in this whole thing. Not every application checks revocation, right? So web browsers, they may not check revocation, because if you're building a web browser and you want it to be the fastest web browser ever in the history of the world, well, you can certainly speed things up by not checking revocation. So where revocation is typically enabled is typically, I believe, enabled on domain controllers, and it's typically enabled on radius servers. So radius servers are usually used to authenticate VPN and wireless clients. So that's somewhere where it's almost always checked. So there's where you could run into some issues. And some of those are kind of critical. Like, you don't want to have, your customers or your users dropping off the wireless because they can't check revocation. So it's definitely something to be concerned about. In fact, it's probably the biggest issue you can run in terms of all this stuff is, you have everything in place, and then for some reason the offline root CRL expired and you never thought to boot that thing up and publish a new CRL. So that's where like a majority of the issues come from. Here are some examples of where you can see some errors in the Windows GUI. So in this first one, we see asserts not trusted. In the second one, we see the chain can't be built. And in the third one, we see again that the chain can't be built. Again, in this video, I'm not going to go into troubleshooting. I'm going to do a separate video where I'll go into troubleshooting certificate validation and some of the different tools and commands you can use. But if you want to really do like a real quick spot check in the Windows UI, there's some information that you can get to determine if there's some issue with validation. So that's all I have for today. So thank you for attending. Like I said, I'll do some troubleshooting stuff in a future video. If you like this video, definitely recommend it to other folks. If you have any questions, you can send them in the comments, or you can go to my website. And you can basically https://xdot509.blog, and you can go there and you can post comments as well, or you can also check out my content. And the last thing I will reiterate is, again, this is a series on learning kind of PKI, starting from the basic fundamentals, and if enough people seem interested in it, then I will maybe go into more technical aspects of PKI. So thank you for watching, and I hope you watch some of my future videos. Thank you.